Whoa, dropping things. Good morning, good afternoon, or good evening. This is Mr. P signing on. How is everybody doing today? So today we're going to be doing some guided notes for 10.3 using chords. Now, when I teach circles in 7th grade, I always mention what a chord is. And then I quickly say, and as long as you know what it is, you're good, because the truth is you're not going to use them until 10th grade. And here we are in secondary math 2, theoretically in 10th grade. Let's go ahead and see if we can use our chords for something. Perpendicular chord bisector theorem. If a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. Huh? That is, if EG is a diameter of EG and EG is perpendicular to DF, then HD, this distance, is congruent to this distance, HF, and the arc GD is congruent to this arc, FG. Cool. Perpendicular chord bisector converse. If one chord of a circle is perpendicular bisector of the other chord, another chord, then that first chord is a diameter. That is, if QS is a perpendicular bisector of TR, then QS must be a diameter of the circle. That is, if I have a chord, its perpendicular bisector must be a diameter of the circle. And that is very helpful. That is something that absolutely comes into play in finding diameters of circles. And finally, equidistant chords theorem. In the same circle or in congruent circles, two chords are congruent if and only if they are equally distant from the center. That is, if you can draw a right angle from the center to here and the center to here, these two distances need to be the same. And if that's true, then these two chords are going to be congruent. So using congruent chords to find an arc measure. If the measure of PQ equals 130 degrees, find the measure of RQ. Now, since PR and QR are congruent, then the arc PR and the arc RQ are also congruent. So that means that if PQ here is 130 degrees, now there's 360 degrees in a circle, so the rest is going to be 360 to minus 130, which is 230 degrees. So PRQ is 230 degrees, but I just wanted RQ. But since I know they're the same, I can just divide it in two. 230 divided by 2 is 115 degrees. So the measure of arc RQ is equal to 115 degrees. That looks like a 2. There. If the measure of PR equals 100 degrees, so this is a totally different situation, so I'm going to actually erase all this. If PR is 100 degrees, so if this is 100 degrees, what is PQ? Well, if PR is 100 degrees, then so too is RQ, because if these are congruent, then these are congruent. Which means if I have 360 degrees to go around in a circle, I need to take away 100 degrees twice, which is really the same thing as taking away 200 degrees, which leaves 160 degrees left over for PQ. You know what? I should probably write down that the measure of PQ equals 160 degrees. Perpendicular chord bisector theorem. Find the value of x. So since we're assuming that PR is the diameter here, then, and actually we know it is because it makes a perpendicular line. It's perpendicular with the, well, I guess we have to assume it is. It's true. We have to assume that this is going through the center T. And that means that these two segments are congruent, which means in this case, x is just equal to 11, which is nice and easy. Now over here, if this is true, this is really a diameter, then the chord GE has a perpendicular bisector, which means that this is the same as this, which means that this is the same as this, which means that x is equal to 65 degrees. And finally here, if these two are the same, because of their cut by that perpendicular bisector, that diameter, QS, that means that they are the same measure. So 9x minus 3 equals 7x plus 5, which we solve the normal way. Subtract 7x from both sides. That leaves me with 2x minus 3 equals 5. Add 3 to both sides, and you get 2x equals 8. Divide both sides by 2, and x equals 4. Now, that's all it asked for, but in case it ever wanted you to put that back in there, like it was like, hey, what is the measure of P, PQRS, PT? Then you would plug that back in. 9 times 4 minus 3, which is 36, minus 3, which is 33, whatever units it is that we're measuring with. Equidistant chords theorem. Find the radius of the circle. So we know that this distance here is 18 and this distance here is 18. And we know that these distances here have to be the same. So we know that those two are the same. That is, so 6x minus 5 equals 13 plus 4x. I have a suspicion of something here, which we'll talk about in a minute. Subtract 4x from both sides. 2x minus 5 equals 13. Add 5. 2x equals 18. Divide both sides by 2. And x equals 9. So x equals 9. Okay, now I know what you're wondering. How do those 3 squiggles get there? Sorry, weirdness. No, you're actually wondering how does x help us? Well, how x helps us is that it's going to tell us this length st, because it's 6 times x, which is 9, minus 5. And 6 times 9 minus 5 is going to be 54 minus 5, which is 49. Now again, how does that help us? Well, I know that WT is the radius, if that's the center there. So from W to T is the radius. So we actually have a right triangle where one leg is 18, the other leg isn't 49, it's half of 49, which is 24.5. Which means this right triangle, let's see here, I'm going to put a little box around it. I'm going to go ahead and redraw it over here as best I can, maybe not with dashed lines. Let's see here. Let's see, right there. There you go. So this distance is 18. This distance is 24.5. And that distance is the radius, which is what I want. So we do the Pythagorean Theorem, 18 squared plus 24.5 squared is equal to r squared. So 18 squared is 324. 24.5 squared, 600.25 equals r squared. Add those together, 324. I get 924.25 equals r squared. Take the square root of both sides. Don't worry about the negative result because it's a distance. 924.25, take its square root, and you get that r is approximately 30.4. Very good. Oh, that was it. Well, folks, there you go. Using chords. I told you it was going to come up if you had me as a 7th grader, which that would be crazy. If so, hey, how's it going? How are your folks? It's great to see you again. If you didn't have me as a 7th grader, how are your folks anyway? I don't know. I'm going to leave before this starts getting weird. This is Mr. P signing off. If you have any questions, make sure you ask your instructor, send them a message, and I hope you have a most excellent rest of your day.